Okay, so yesterday we made our unit circles. We're going to use those today because it'll help you with the degrees. But we got to talk about how we draw things, right? You're so used to in the past of doing trigonometry of just, in that small little triangle, right? Now we're dealing with trigonometry in the full 360 degrees. Okay, so let's look at this here. This first picture here is our basic diagram, right? We have our x and our y. And there's our basic triangle. Were we drawing these triangles yesterday? We drew them in quadrant one, right? Remember, we did it for 30, we did it for 45, we did it for 60, right? Just the difference in lengths, right? Like root of 3 over 2, root of 2 over 2 and a half. Remember, those were the lengths if you actually look on your thing. What we can talk about then, we can talk about initial arm and terminal arm. What do you think an initial arm is? Where it starts, right? What about a terminal arm? Where it ends, right? Terminates, where it ends. Okay, does that make sense? Okay. The initial arm is always at what degree? 0 degrees, right? And then all we do is go through it, we move it. And wherever it stops, that now becomes the terminal arm. But that terminal arm can be in any one of 4 quadrants, right? Could it stop in quadrant 1? Yep. Could spin all the way over to quadrant 2, all the way over to 3, and all the way over to 4, right? Can stop in any one of those. And it actually forms something, and you'll see, I'll talk about this in a bit. It forms like a bow tie. Right, you guys know what a bow tie looks like? Kind of like an X? It'll actually form that pattern. Okay, so here's our basic triangle. So here's our X value, here's our Y value. Why is this thing called R, by the way? Radius, because it's the radius of a circle, right? Unit circle, right? If we actually spun a circle around it, R would be the radius. If I gave you X and Y, could you find R mathematically? If I said X was 3, well, actually that's wrong. If I said Y was 3 and X was 4, what would R be? 5, right? It's called a Pythagorean triple, right? A 3, 4, 5 triangle, right? So you can figure that out mathematically, use Pythagorean theorem. Okay. Now, sine, cosine, and tangent actually have more than just formulas. When we were talking about coordinates, when we were talking about just plain coordinates, what was cosine and sine? Do you remember from yesterday? Cosine was X, sine was Y. Easy way to remember that is alphabetically, right? Now, basic trigonometry that you learned, there's ratios, right? Remember, adjacent, opposite, and hypotenuse. Okay, now think about this for a minute. Sine, so, S-O-H. Sine is what? Something over something. Opposite over hypotenuse. Now look, what's the opposite? Y, what's the hypotenuse? R. Anything? Cosine. Adjacent over hypotenuse. Adjacent is X, hypotenuse is R. Tangent, opposite over adjacent, Y over X. Does that make sense? And didn't we say that yesterday, tangent? Was it the second term over the first term, Y over X? Remember that? I could ask you on your unit circle, what's the tangent of 45 degrees? Root of 2 over 2 divided by root of 2 over 2, which is 1, right? Remember this from yesterday? Yep. Now, this works for any size angle. If you look here, what was the initial arm on this picture? Where was it? At 0. We spun it all the way around, and where did it terminate? Which quadrant? It terminated in quadrant 2. Okay? Well, to make this easy, we have something called a reference angle or related angle. See? Related angle or reference angle. Sometimes you'll see me write it, well, actually all cases, you'll see me write it as theta R. Right? That's theta, it means an angle. Right? What does the R stand for? No, not in this case. Related or reference angle. Okay? Because I could say to you guys, hey guys, I have a reference angle of 30 degrees. And it actually could have 4 answers. One in quadrant 1, one in quadrant 2, one in 3, and one in 4. Okay? And I'll show you in the next little one. It's actually going to form a little bow tie. Okay? So in this case, there it is again, bang. The only difference is X and Y. Now, look at this one. What can you tell me about Y here and Y here? They're both what? They're all both on the outside because they go up and down, but think about where they are. Are they above the x-axis? They're both positive, right? So in this case, our y is both positive on that one and on this one. Yes, they are. What about the x here? X is positive, but here, x is negative. Okay. What about r in both those cases? Well, we don't know the numbers, but is r positive or negative? Is the hypotenuse positive or negative? Let's find out. You'll find out something really interesting about r in a sec. Okay, so let's talk about this. Quadrant 1. We're gonna fill out this chart. This chart will make sense. This chart helps you determine things later on. So in quadrant 1, let's talk about the sine, cosine, and tangent. Okay, sine is what? Y over r. Well, I guess we better talk about r before we do anything. For instance, if this was 3 and 4, what would r be again? 5. Is 5 positive? Because you take the 3 and you square it. You take the 4 and you square it. You add those two together, and then you take the square root of it. Right? So, in this first one, is sine positive or negative? Positive divided by positive is going to be positive. And that's what we have there. Is it positive? Okay. Let's talk about cosine. Cosine, positive divided by a positive, which gives you a positive. So what's cosine? Positive. And tangent, positive divided by positive, which gives you a positive. Oh, well, that's really easy then. In quadrant 1, are they all positive? Every single time we do it. Cosine, sine, or tangent. Quadrant 2. Now, quadrant 2, the one right above it here, which one's positive, the y or the x? The y. The x is going to be? But what about r? Let's plug some numbers in for a sec. Let's pretend y is 3, and let's pretend x is negative 4, right? Because it's negative, right? What's 3 squared? 9. What is negative 4 squared? Positive or negative? Positive. 4 and 16 is 25. What's the square root of 25? 5. So what is r? Is r positive or negative? Positive. Oh, okay. So in quadrant 2, r is positive. Okay, let's do this again then. So let's do with sine. Sine is y over r. So y is positive. R is positive. So what is quadrant 2 for sine? Positive. Okay, now I'm not writing a positive. I'm writing that shorthand. You ever seen that before? Plus VE? Yeah, positive. Negative would be like a dash VE. Just another way of writing it. That's the way I write it. Okay, let's try cosine. X is negative. R is positive. A negative divided by a positive is a negative. Oh, okay, cool. All right. What about tangent? Tangent is y over x. Y is positive. X is negative. Positive divided by negative is a negative. Now, does this look familiar when we talked about coordinates within those quadrants? Think about quadrant 1. Both x and y are positive. Quadrant 2, x is negative, y is positive. What about quadrant 3? Both negatives. What about quadrant 4? X is positive, y is negative. Right? This is kind of the same thing, isn't it? We're just happening to include what now? What letter? R. We're talking about the radius. Okay, so let's do the next one. Quadrant 3. So quadrant 3, if we drew a little picture here, and I'll just draw it on the side. I'll draw it here. If we talk about quadrant 3, we're talking about down here, right? This is what we're talking about. So x is negative, y is negative. What about r, though? It's still positive. Think about that for a minute. Negative 3 and negative 4. When you square negative 3, you end up with a positive. When you square negative 4, you end up with a positive. When you add those together, you still get your 25, and you take the square root, it's still positive.
Why when you square a number, a negative number, it ends up like something?
Because what's a negative times a negative? What's your basic rule for negative, right? So when you say negative 3 squared, it doesn't mean the negative's out the front. It doesn't mean you take the 3 squared and then times it by negative, right? There's a huge difference between negative 3 squared, like in brackets, and negative 3 squared like that, right? This one's positive, and this answer's negative, right? Because it's outside the brackets. Both of these are in the brackets, right? Because we're doing the negative 3 squaring the whole thing. So, in this case, in quadrant 3, right, this would be quadrant 3 down here, 3. X is negative, y is negative, but r is positive. Okay, so let's do the chart here then. Sine is y over r, so it's a negative over a positive, which would be a negative, right? Cosine, a negative over a positive, which would be a negative. Now tangent, careful. A negative over a negative is a positive. Now you should remember that from yesterday. Remember when we did the, when we found the tan of, what's the 45 in quadrant 3 that we wrote on there? Where's our 45 in quadrant 3? 225 degrees? Is that right? When we did that, it was a negative divided by a negative, so what did it come out to? Positive 1, right? It makes sense. Okay, so that's 1, 2, 3. What about quadrant 4? Quadrant 4, down in the bottom right-hand side. X is positive, Y is negative, R is positive. So where's R in every single one of these quadrants, by the way? Positive, right? You can write that down if you want to. R is, like the hypotenuse, or R is always positive in any of the 4 quadrants. Just to make your life a little easier. Good. Okay. Quadrant, let's do sine. Sine is y over r. Y in quadrant 4 is negative. R is positive, so the answer is negative. Cosine. Cosine is x over r. X is positive, r is positive, the answer is positive. And tangent, y is negative, x is positive, the answer is negative. Sorry, what? That thing? Yeah, that, what is it? Oh, is that what it is? Oh, but you have to start where, though? No, I think you start in quadrant 2, don't you know that? Oh, there you go. There you go. There's an acronym. If you like soup, I guess. What if you don't like soup, then you can't remember it? You gotta know what it is. Now, I think at the bottom of the page there, you have a bit of room. Just the bottom. I want to draw one thing just before we get going. I will come back to this, but I want to really show you the bow tie. Right? Because the bow tie will help you kind of organize stuff later in life, or later on. So what you're going to do is draw a little x and y axis. So a little x, a little y, oops, a little y. And basically what I, nice voice crack. Basically what I want to draw on here is I want to draw a bow tie. Because this will help you with the theta r. Because once you know the related angle, you can figure out what all the angles are that relate to it. Huh? Make sense? Okay. So what I'm going to do is I'm going to draw a bow tie. Now watch. This one's going to go here. This one's going to go here. And I'm going to join them up. Now, does that look like a bow tie? That? Fancy bow tie? This will make more sense as I go through it. I just want to kind of introduce this. Now, what are these angles right here? All these angles here. These are all 90 degrees, right? These are 90, and these are 90, right? They have to form 90. Now, what can you tell me? I'll put little red dots, I'll put blue dots on here. What can you tell me about this angle, this angle, this angle, and this angle? They're all the same. And guess what angle that actually is? No, I don't care about the number. What angle do you think it actually is? Theta r, right? Because they're all the same, right? That's correct? So all of these in this case are theta r, theta r, theta r, theta r. So for instance, if I said theta r is 30 degrees, how many possible answers could there be? 4, right? Now the difference is where we start and where we end. We always start in the same position. Where do we start? At 0. Now, okay, think about this for a minute. So here's 0. We tip up 30 degrees. What's theta r? 30 degrees. Where did our terminal arm end? At what degree? 30 degrees. Is that correct? Now careful. Now watch this. This is cool. What's this theta here? Theta r, right? Where did it start? 0, 0. It tipped up, and where did it end? Now careful. Where did it end? How'd you get that? 180 minus the theta r, right? Is that correct? And it ended up at 150. Okay, now watch. What's this in the third quadrant? What's this theta r? What's this theta r right here? 30. Now where does it start? 0, spins all the way around. Where does it end? How do you get that? 180 plus theta r. 180 plus 30 is 210. Okay? Fourth one. What's this theta r right here? 30. We start at the 0, 0. We spin all the way around, and we end up where? 330. How did we get that? 360 minus theta r. So if I said the answers, if I said theta r is 330, if I said theta r is 30, how many possible answers could there be? 4, right? 30, 120, 210, or 330. Okay? What I'm going to give you is we're going to do a method where you actually decide which one's which. Okay? So flip the page. Okay, example number 1. Here we go. Sketch a diagram out of an angle of 330 degrees. Label the initial side, the terminal side, the angle, and the reference angle. 4 things we're going to label. Where the heck is 330? Which quadrant? 4. Okay. Now guys, it says sketch. So do you need to grab your protractor? No. Right. We were sketching 330 degrees, right? We're sketching it. We're not actually writing it out really, really high in here. So where is it? Somewhere in here? Okay. I'm going to draw... let's get that'll work. A line from there to there. Yep, so there it is. There's 330 degrees. How do I label all this junk on here? Where's my initial arm? So this right, is that the initial arm right there? Initial arm, or initial side. You'll see initial arm, initial side, it really doesn't matter what you call it. Where's my terminal? Well, so what is it? Is it the line I just drew? Yeah, that's the terminal arm. That's where it terminates. Right? It's spun all the way around. This little guy right here, this is my terminal arm. Terminal arm. Okay, now, got to label 2 degrees here. Let's do the reference angle first. Let's do theta r. Where is my theta r? Is it where? Okay, between the terminal side and the initial side. Is that where our theta r is? Is it this little guy right in here? Okay, so theta r is that one because that's my reference angle. If you notice, is that one piece of that bow tie? Okay. Now, where is my actual angle? It's all the way around. Starting where? Starting here, all the way around. So here, I'll do it in a blue color. So starting here, spinning all the way around is my angle. Right? This is the angle. And what is it in this case? How much was it? 330 degrees. Now, if I gave you 330 degrees, could you actually tell me what theta r is? What is it? 30, right? 360 minus 330. So you can actually tell me that that theta r is actually 30 degrees. Is that everything now? Initial, terminal, the angle, and the reference angle. Yeah? Easy peasy? Okay, let's try the next one. Go! This one says to determine the reference angle for theta equal to theta equal to 240. Okay, where's 240? Is it in the third quadrant? Okay. So what you might want to do is, if you're unsure about it, draw it in. You're going to draw that line in. So it's somewhere down here. Now, does it really matter where I draw that line in? Like, am I actually measuring it with my protractor? No, I don't care. I'm just going to draw it in. There's my angle. And the one I'm interested in is, if I start all the way from the initial arm and come around, what is that number right there? What is that angle? How much? 240 degrees. Now, where is my theta r? What line is it between? Well, what's this line called that I just drew in this black one here? That's the terminal arm. It lies between the terminal arm and the, no, careful, where's the initial arm? 0, 0. So, well, that would be 240 if we said that, right? The line. What degree is that right there? 180. So basically, the theta r in this case lies between the terminal arm and the 180 line, the x-axis, right? Does that make sense? That's, if you look back. Where is it here? Look back at the bottom here. You see the bow tie? Is it between that and the 180? This one is, the next one above it in the quadrant 2 is a little bit back from 180. But if you notice, it's always the 360 or the 0 line in the 180. Everything always comes up to the x-axis. Theta r always comes up to the x-axis. Okay? Let's go back here. Oops, sorry. Oops. So, theta r, this little guy right in here is going to be theta r. How do we calculate it? If we want to find theta r, we take what? 240 minus 180, which is 60. Now, you're going to see sometimes it's written a specific way. Sometimes they won't just say theta r. They'll actually put theta and the number of the quadrants. You'll see that sometimes written that way. So sometimes instead of theta r, they'll have a theta, and what will they have down in this corner here? 3. Why 3? It's in quadrant 3. And what will it be in this case? 60 degrees. Does that actually make sense when they write it theta 3? Because you basically know that's the reference angle in quadrant 3. Not bad? What do you think? Easy? It's really not that hard, since you learned a lot of the basics yesterday in the unit circle. That stuff we did yesterday really leads into this. Okay. Now, an angle in quadrant 2 has a reference angle of 30. What is the measure of the angle? What's the actual angle? What? I don't know. Sure, draw it for me. No, draw it on your own paper. Did you want to draw it on the board? Well, draw it on your own paper. See what you get for me. See if you can draw this. And again, it's a sketch, right? So you have to be really exact when you do this. You know which quadrant it's in. You know that the reference angle is 30. You know which line it goes to. Then you can tell me what the real angle is. Excuse me. I'll draw it out in a minute. You probably don't need that much time to actually do these. All done? Really not that hard, is it, so far? What's going to happen is, well, I'll tell you in a second. Okay, what do I do? I draw a line. Where am I drawing this line? In which quadrant? 2? So somewhere over there. Could I put in, where do I put my 30? I don't know where to put my 30 in. Well, just call it the x-axis, right? Because it's between the terminal side of the x-axis, right? Because that's, well, yeah, I see what you mean by negative x. You're talking about it in that quadrant there. Okay, so theta r in this case is how many? What is it? 30 degrees. So what angle am I actually looking for? No, that is the reference angle. Yes, the angle between the terminal and the initial. That's what I'm looking for. So I'm looking for this one way over here. I'm looking right from the start. Right? That's what I'm looking for. So how do we figure this out? So the angle we're looking for, theta, is 180 minus 30, right? Because we kick back up, minus 30, which is 150 degrees. Is that correct? Cool. It's really not that hard. Now, the only thing that you're going to find in the lesson coming up today is there's a couple math questions where they start at the origin and they tell you, hey guys, go, in this case, look at this here. If I asked you, I said, okay, we start at the origin and I want you to go 3 miles west, which would be left, right, and 4 miles north, which would be positive. So would we end up there? So what are the coordinates of this one? Negative 3, 4, right? Could I actually ask you for the distance right there, which would be Pythagorean theorem? Could I actually ask you for the angle now? Yeah, we could do all the angle stuff. We know the angles, right, SOHCAHTOA, because you actually work backwards and find angles. The easiest way is if you knew the reference angle, then could you find the actual degrees? Yeah. And that's how they measure. I don't know if you ever noticed if you ever watch movies and they say 40 degrees northwest north, right? North by northwest or west northwest. Right? They always give you a degree of bearing. You'll see there's a question coming up in the questions that are like that. So what do you think? Yeah, easy? Not bad? Don't worry, it'll get more complicated. In case you're all thinking, oh, this is so easy. It'll get harder, don't worry. Okay, do the questions you have. What's Tuesdays? Tuesday work class? Remember, there's no school on Monday. Is Tuesday work class? I can't remember. Look at your sheet there. Yes, perfect. That's perfect then. Okay, you guys got lots of time to work on this.